Hello, my dear friends. I hope everyone is fine. Today, we are going to learn something very exciting, and we would look into different topics. The first one is what is a graph? Then we would see how we can find shortest paths in a graph, and we would look into a very classic algorithm called the Dijkstra algorithm. So let's start. So first of all, what is a graph? A graph is a very simple data structure which is used to model connections between different entities. So let's see what we mean by this. So we will look into some famous graphs. This one is a graph of social media, different social media networks. So here we see Twitter graph interacting with LinkedIn graph, and then there is an Instagram graph, and then there is a Facebook graph. So in this graph, we see that the entities are actually the users, which have made profiles on the respective network. And the connections are these yellow lines which are joining them with each other, with the network, and so on. And similarly, this one is a bit complicated graph, and it is a very small subset of our internet, where we see red nodes as websites and blue connections as different links to different websites. And in the center, we can see all of them are converging. So it might be a search engine at the center of this network. Maybe it's Google. So this is a brief overview on graphs and how we can see graphs and what are the graphs. So if we try to define it now formally, we see that a graph has nodes which are entities, and it has edges which are connections. So in this graph, there are four nodes A, B, C, D, and then they have edges which are connecting these nodes with each other. And there are many types of graphs. So one of these is called weighted graphs. In this graph, we have nodes and edges, and we also have a weight associated with each edge. So let's try to understand this with an example. Suppose this is a graph showing four cities which are connected to each other. Then A, B, C, D are cities, and these edges are routes. And this particular weight can be the traveling time from one city to another city. So we, we might come across this sort of example, and we might want to find out what's the shortest route between any two cities. Suppose we want to say we want to find out what is the shortest route from A to D. So there can be many paths. Suppose we can travel from A to C, then B, then D, or maybe A to B, then C, then D, or maybe from A to B and then to D, and then maybe we can travel from A to C and then to D. All of these are connected, and there can be many possible combinations of paths we can take. So in order to make sure that we are finding shortest path, we have to calculate it, and how to calculate it, we would use the Dijkstra's algorithm. So this is the basis of our shortest path finding problem. So we have to find a shortest path in a graph from one node to another node. Then there is to solve this problem, there are many algorithms, but one of the very famous algorithms is Dijkstra's algorithm, and it was conceived by Edgar W. Dijkstra. He was a brilliant computer scientist in 1956. This is a very classical algorithm, and it is taught in nearly all the computer science majors in the universities. I was also taught when I was studying in my major for my bachelor studies. So let's dive into it and see how this algorithm works. So for any algorithm, there are finite number of steps which help in solving a problem. So this is a definition of algorithm. So Dijkstra also has some steps. So the first step is mark all the distances as infinity. So we will mark all the distances on nodes as infinity. Here we can see this in the list as well. Then we have to select a source node from where we want to traverse the path. So suppose we have A as our source node, then we have to update distances from this node to its neighbors. And so from A to its neighbor B and C. Then we have to mark, when this process is done, then we have to mark this node as visited, A is visited, and then we would go to the next neighbor and repeat this process. So we have to repeat this process until all the nodes are visited. And we also see that in order to update distance, we have a heuristic or a measurement, which is actually the heart of this algorithm. This measurement is saying that we have to find the current distance, a minimum between the current distance on the node and approaching distance plus its cost. let's try to understand this with the example. So let's move to the first step of algorithm. We have updated some distances. For example, we have chosen our starting node as a source node as A, and the distance from A to A is 0, which we know. Then we now we let's try to find out the update the distance of B. So according to our slide here, B has the mean distance of infinity. So current distance is infinity, and then when we the approaching distance is from this node. This node has a distance of 0, which is approaching distance, and the cost is 2. So we have to find minimum between infinity and 2, and that's why it would come out as 2. So this distance is 2. Similarly, we would calculate the distance of A to C as 6. So we have updated these distances, and we have also added the neighbors in the list. So A has been visited. So A would come in this visited list, and its neighbors are now in the neighbors list. So we would repeat this. We would select the first neighbor from the neighbors list, and we would visit it and run the algorithm. Similarly, when we run this algorithm on B, we can calculate the distance of D, which is 2 plus 5 is equal to 7. And there is no other connected node is already visited, so we won't go back. And this is a very short step. Here we have labeled this distance. Now, when we move next step, we choose the C as our node, and here we can see that A is already visited, B is already visited, B is also not connected to C, so we only have a connection C to D. And when we try to update the distance, we see that D is already at minimum distance, so we won't update it. So C has added no new information. We are just add this into visited, and now in our neighbors array we have neighbors list we have D. So we would take it out and add its neighbors into the neighbors list and update the distances. So from D to G, we have updated the distance as 7 plus 15 is equal to 22. And from D to E, we have also updated the distance 7 plus 10 is equal to 70. So when we calculate this distance, we would see that these are the shortest possible distances at current point. Now we would choose the next neighbor, which is E, and we would add D into our listed list. And now we have also added E into our listed list and updated the distances. So from E to G, we cannot add any new information. Similarly, the other neighbor F, we have already added this. We have calculated the shortest distance from E to F, and which is 19. So we have added updated this, and we have added E2 visited list. Now, when we run this algorithm on G, we see that no new information is added because already all the connected nodes are at their shortest distances and most of them has been visited. Similarly, we would add the last node, which is F, and we can see that this also has no new information because this is the last node. And here we can see that our algorithm has completely run, and we now can see that we have calculated all the shortest distances from A to any node in this graph. So suppose if you want to get to G, then the shortest distance is 22, and the route is very simple. So first we will go to B, then we will go to D, and then we go to G. Similarly, if we want to go to F, we can see that we have to go to B, then D, then E, and then F. So from A's point of view, we have calculated all the shortest distances. This is how this algorithm works, and this is how we calculate this. So for this video, we would stop here, and as we have seen how the Dijkstra algorithm works, now we would in the next video, we would try to solve a real-world problem involving shortest path distances, and we would implement this algorithm in C and C++. Thanks for watching, and I will see you in the next video.